So we've been looking at working out how to do better testing of our products for the certification testing that things will go through. We'll test the electromagnetic kind of radio waves given off by the electronics. And one of the ways we can test that, we hope, is using a transverse electromagnetic cell, or a TEM cell. This is the first prototype one that we've built, just to see if it works, basically. So Chris has been carefully working out the dimensions. There's a whole bunch of academic papers he's been reading up, and it's effectively like a coax cable you can put things into. It's the easiest way of describing it. So there's a conductor across the middle, and then the shielding either side, which is expanded out. This is an asymmetric one, which means we get a bigger area here, and we don't need loads more space above. And then there's a terminator at the far end, and at the start of it, we have it plugged into a spectrum analyzer. And that should let us use an area kind of around this sort of size in the cell, put our electronics we're testing into that, and then measure on the spectrum analyzer what it's generating. So we didn't know if this was going to work at all, which is why, as I say, we've built this kind of cardboard and tin foil and some nice laser cut bits of MDF just to kind of assemble it all, and we're doing some initial tests. So we've got a signal generator, and this isn't super special. It can generate up to 20 megahertz, but that's enough to let us see if the kind of principles work. So we are, if I take the cable from the signal generator, which I've just looped around to make a little kind of noddy antenna, and then the spectrum analyzer is measuring from 10 megahertz up to 30 megahertz and giving us signal strength at each of those frequencies. So we can set these signal generator to kind of 11 or 12 megahertz, and then we get to see a nice spike. And if we increase the frequency, we can see the spike moving across through the frequencies. So that, seems to be doing what we're expecting. We've chosen 10 to 30 megahertz because the really obvious thing that's generating RF on the Museum in a Box boards is the NFC RFID reader, which operates at 13.56 megahertz. So if I stick that inside the TEM cell and then plug it in, and now it's booted up, and then we see a kind of periodic pulse at 13.56 megahertz, which is the NFC reader. It spends some time listening to see if anything else is trying to talk to it, and sometimes generating the RF, so that's showing up quite nicely on the spectrum analyzer. So our next steps are going to be to work out what the ranges are, what the limits are for the different testing that we need to do, and then work out how to build a slightly bigger, because we need a bigger testing area and more robust TEM cell.